I'm going back home where I'll see the hills kiss the sky and the sun's a bright balloon. Sprinkle me with desert stardust and let me lie neath that old Nevada moon, neath that old Nevada moon.
Hello, my name is Garrett Barmore. I'm the curator of the W.M. Keck Earth Science and Mineral Engineering Museum, and welcome to another field trip edition of Mineral Monday. Today we're at the Newmont Mining Operations Twin Creeks facility. Let's go check out an active mine. Today we're at Newmont Mining Operations Twin Creeks facility, and I'm with Evan and Zach, who are going to take us through the process of mining for gold. So Evan, why don't you tell us about what's happening behind us?
So behind me here is the Vista pit. It's actually the smaller of our two pits here at Twin Creeks. We mine oxide ore here. That ore is microscopically disseminated with gold. A lot of people think of gold in big nuggets, and in fact, our trucks may only have 10 ounces of gold within them when they haul up. You can see in the pit the drills that are preparing blast holes. They will be loaded with explosives and shot on the bench. The shovel will then load that ore onto the haul trucks, who will take it out.
So what happens once the ore leaves the pit?
Well, we can't just sell the dirt, so we're going to send that over to process.
Yeah, once the ore is loaded in a truck and is brought to the processing facility, I will go through the process of extracting it, and we'll go from there. If you'd like, I can take you over there and show you.
That'd be great. Let's head on over.
All right.
Oh. So Zach, where are we right now?
We're currently standing in the Sage Mill grinding circuit, where we process the run-of-mine ore into a fine slurry for gold recovery.
Cool. So could you tell us a little bit more about that process?
Yeah, so in this particular circuit, we'll take large run-of-mine ore. As we process it into a fine slurry, we unlock the sulfide matrix to allow us to do a cyanide leach later on in the process to recover our gold.
Cool. Why don't you show us the next stop in the process?
Certainly. Next stop, the acidulation.
Very good.
So we're at the next stage in our process, which is acidulation. At this point, we're allowing the sulfur in the ore to naturally mix with the water and start making a sulfuric acid, bringing the pH down in our process.
And why is that important?
So we have to bring the pH down for our oxidation process. We're basically doing like you'd rust a bike chain essentially. So if we were not doing that, we'd be roughly at 10% recovery. Once we oxidize it through chemical reaction, we're able to get upwards of 90% recovery and see that bright red slurry behind us.
Cool. And oxidation is essentially a rust, correct?
It's exactly. It's a rust.
Cool. So let's check out what's next.
All right, let's do it.
Cool.
So we're walking through our carbon and leach facility. This is where we add our cyanide and allow the carbonate I had in my hand, allow those to interact, and then that gold will load on there. The carbon acts as a magnet essentially with a negative charge. All the gold and silver floating around as they become a solution, adheres to that on the surface, and then that particle is larger than on the carbon, where we can pull it out from the slurry, separate it, send it off to a facility to strip it off, reverse the reaction, and that can go onto our refinery and be poured into a gold doré bar.
Well, Evan and Zach, thank you so much for showing us around your facility and showing off the modern gold mining process here in Nevada. And I'll see you next Mineral Monday.
I'm going back home where I'll see the hills kiss the sky and the sun's a bright balloon. Sprinkle me with desert stardust and let me lie neath that old